I am Anil Kumar. In this series, we have discussed first and second derivatives. Here is a test question for you. The question is, let f of x be equal to x minus 2 times x plus 4 whole square. List the critical numbers or number of the function. What will these critical numbers represent on the graph of f of x? And C is at x equals to 0. Second derivative of the function will be positive, negative or 0. Explain your answer. You can always pause the video, answer the question, and then look into my suggestions. Now, one of the options is we can actually sketch the function. So I'll make a smaller sketch here. We'll work out the details later. As you can see, the function has two zeros. One is at 2, the other one is at minus 4. It's a cubic function, right? It's a cubic function which has zeros at x equals to 2 and at x equals to minus 4. And this 0 has a multiplicity of 2, right? So it'll like bounce back. Leading coefficient is positive. So looking into these conditions, we have leading coefficients as positive, so it's going to end up in quadrant 1, right? And the zeros, let's say, are at minus 4 and 2, right? So somewhere there. So at 2 is a linear 0, and at minus 4 it is of order 2. So we could actually let me write down the zeros. Let's say this is minus 4 for us, and let's say this is 2 for us. Correct? Let's say this is 2 for us. So at 2 is a linear 0, so the graph will actually be kind of like this. And if I substitute 0 here, I get 16 times minus 2 is minus 32, right? So the graph will be kind of like this, right? So approximately kind of like this. So that is going to be the shape of our graph. It will only help you to answer the question, but the question really is, list critical numbers of the function. So what are the critical numbers? Well, let's try to understand. The critical numbers are not the zeros, right? The critical numbers are the point where we have first derivative as 0. So there are two critical numbers, one somewhere there and this one. These are the two critical numbers, the turning points, where the derivative is 0. So what we need to find is exactly this point, right? So we are given the function f of x as x minus 2 times x plus 4 whole square. Let's find the derivative of this function. So applying the product rule, derivative of x minus 2 is 1. So we get this as x plus 4 whole square plus derivative of this, which is 2 times x plus 4 times x minus 2. Now that becomes the derivative. To simplify, we can take x plus 4 as common, and we're left with x plus 4. And here we are left with x minus 2 times 2, which is plus 2x minus 4. Or I could write this as x plus 4 times 2x plus x is 3x, right? 4 minus 4 is 0. So that becomes our derivative, and from here we can say that the critical numbers are what? Well, the critical numbers are when it is 0, right? So for that we can equate this to 0. So we get x equals to 0 and x equals to minus 4. So that means this turning point is basically on as a y-intercept, okay, which is at x equals to 0. So these are the two critical numbers. So the solution for part A is the critical numbers. We have two critical numbers. Which are at x equals to 0 and at x equals to minus 4. Okay, so we get our critical numbers. Now, Part B is, what will these critical numbers represent on the graph of the function? So from this sketch, you clearly know that at x equals to 0, we have local minimum. And at x equals to minus 4, we have local maximum. This is from the graph. Now, how do you analyze the derivative to figure this out? So let's do that. So we'll actually analyze f dash x to explain. Right, that is kind of important to understand. So what we are given here is that the derivative of this particular function is basically 3x times x plus 4. Now, if I analyze, we have two zeros here, right? One is at x equals to minus 4, the other one at 0. We can take test point, let's say minus 5, minus 1, and plus 1. And in these test points, the value of f dash x, if we analyze, at minus 5, this is negative, both are negative, right? Since both are negative, we get positive. So it is increasing in this interval. At minus 1, 3x is negative, however, x plus 4 is positive, so we get a negative here. So here the graph is decreasing, correct? Now, at 1, both are positive, so the graph will be increasing. So that clearly shows that since we are changing the rate of change from positive to negative, that means we have a local maximum, and here we have a local minimum. Right? So it's very clear that at minus 4 we have local maximum, and at 0 we have local minimum from the analysis of the first derivative. Is that clear to you? Perfect. Okay. So that is how we are going to do part B, right? What will these critical numbers represent on the graph? They are going to represent local maximum and local minimum. See, at x equals to 0, this point, f double dash, that means second derivative will be positive, negative, or 0. Well, from the graph, we know we can answer part C from the graph. We can say it is concave up, right? And that means that the second derivative should be greater than 0 or positive. How do we do algebraically? Let's find the derivative, right? So let's find the second derivative. Well, let me rewrite the first derivative in expanded form. We can write this as 3x squared plus 12x. So the second derivative will be 6x plus 12, right? So that is going to be the second derivative. At x equals to 0, we get 6 times 0 plus 12, which is plus 12. So it is definitely positive. Is that clear? So that is how we are going to answer this particular question. So as you can appreciate, we could actually answer the question from the graph, which is the best way of answering. However, here the critical number has to be calculated. If it is a multiple choice question, then you could guess this to be 0 and get the right choice, right? Once you have a graph in place, then it is very easy to answer all these questions. But sometimes you may have to do algebraic method as shown here. So I hope that helps you to understand how to solve such questions. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.